Welcome back to From Bits to Bots for our third episode. This week is a double feature, so we're releasing two episodes together, wrapping up our focus on the IDE and the code-specific tips that I have for you all. Go back to episode 2 if you'd like help with how to navigate the IDE and the basic setup of your Arduino. I've said this before, but I want to reiterate. When I began with Project Invent, I'd literally never played with Arduino and had only done some rudimentary coding games with my students. So I began by taking an online course, which was extremely helpful and very thorough. That being said, even as the instructor was going through things and trying to put them in layman's terms, I still found myself going back and pausing and replaying the video and Googling half of what he said. I had no idea why any of the code worked or what the different things I'd typed into the IDE even meant. And that's what I want to focus on in this two-part video release. Specifically, in this video, we'll start with some common debugging strategies, and then in the next video, we'll go over a bunch of the different abbreviations and keywords you see used in the code. At the end of episode 4, we'll introduce our skills challenge, which will take us through the next 5 weeks. So, let's jump into debugging, and I'll show you what I've learned. My first tip is a not so well kept secret that seems too obvious to be right. Sometimes you just gotta Google it. That's right. My first tip is simply to Google the issue you're having and see what other people are talking about online. Now, I know, you're sitting there saying one of two things probably right now. Either one, you're saying, wait, we're 3 episodes into this whole thing and your big tip for me is to just Google my problem? Or you're saying, yeah, okay, but when I do Google those things, what does it all mean and how do I make sense of this gobbledygook? If the first question is you, then I say, yeah, that's it. The best part about the Arduino community is that everyone is sharing online. There are forums, videos like these, libraries, and open source sharing platforms aplenty, and I guarantee someone else out there has done something similar to you. Now, if you fall into that second camp, in which you've already tried Googling some of this, but it just doesn't make sense, or you're not sure what things to Google, well, that's where my second tip comes in. Get used to using the verify button. Let's say I want to run a new code and I type this into my void setup function. Do you see anything wrong with what I've just typed? If you guessed that what I'm missing is a semicolon, you're right. See, if I get in the habit of hitting verify often, I don't even have to remember that semicolon was necessary because the program will do it for me. And it'll spot errors like this, which we call compiling errors. More on those in a little bit. I like to try to remember to hit the verify button after each new scope that I put into a function. If you verify often, you'll get used to reading the error messages and know what to search for when you go to do your Googling. Additionally, by compiling your code in small chunks and taking more time up front to verify, you'll save yourself tons of time in the long run by not having to go back and decode the error messages to find your mistakes. Now, because error messages are inevitable, even if you verify as often as possible, my third tip for debugging is just to learn how to read the error messages so they don't look like complete nonsense. Now, I'll admit, I still don't understand everything in an error message, and why they can't just say, this part is wrong, here's the best way to fix it, dummy, is beyond me. But I've gotten much better at it since learning a few key things. So let's take a look at this code. In theory, this code instructs my Arduino to control a photosensor on a nightlight. So I'll hit verify, and immediately I get all these unsightly errors. Looks like a bunch of gobbledygook. However, if you learn a few key things, you'll be able to read these errors a little bit easier. For example, if we look at this first one, the first line, go all the way to the end, it says in function void setup. So it's telling me where to look up here in my void setup function. I then have directions here for in my sketch, line 5, character 1, and they've highlighted that in orange for me, so I can count 1, 2, 3, 4, 5. Line 5, character 1 is this curly bracket. It says there's an expected semicolon before that curly bracket. So I could put it here. It makes more sense, or a lot of times we put it on the line that has the information. So I could put that back, and then I could verify that. And if I verify this, I still have codes that come up. But if I go to the top, I no longer have that first one that I started with. I could do the same thing for this next one. This next one says that I've got too few arguments in function, int analog, and then whatever this means. This is a great opportunity for you to practice Googling what you have researched or what you have a problem with. So what I would do is I would highlight too few arguments to function and then leave the rest of this out, because it's not likely that somebody else has written the exact same function that you have. But too few arguments to function, I would copy that, go to your favorite search engine and type Arduino, and then copy paste what you've copied there. By doing that, you're going to get tons of information from other people who've gotten this same code and this same error, and they can show what your issue is. In this case, what it's telling me is that I haven't defined what goes into these parentheses, so I just need to tell it which input on my Arduino I want this to go into. So it's A0. I can verify this, and it tells me that I have, that has been taken care of. I still have one error, however, and the issue is that there is an expected unqualified ID before my if. Basically, all this stuff appears to be happening before my if statement and my else statements in a place that doesn't make sense, because I have closed my curly brackets here. So even though it has highlighted this, what it's telling me is everything from here down doesn't make sense, because I don't have a loop for it to be a part of, or a function for it to be a part of. So if I get rid of that curly bracket and then verify this, it now says it's done compiling. I can upload that to my Arduino and it would work completely. Everything we've talked about so far would be considered a compiling error. Missing characters, not declaring a variable, etc. Those are fixable with a little help from Google and just combing back through to make sure that I haven't missed anything obvious. There's a second type of error, however, that is trickier to detect, as it may technically be usable code that I've typed, but it just doesn't give me the output that I want. Those are called runtime errors. Runtime errors are the equivalent of writing down a math problem as 1 plus 2 rather than 1 times 2. Both are legitimate equations, but I'm going to get results that I don't want or expect. Now, I'm going to stop and say that if I get to the point of uploading my code and don't see the output I want, and I've already checked for compiling errors, then I'm not going to immediately jump to assume that it's a runtime error. I'm going to take time to check things like making sure my board and port are correct, and I'm going to check that all of the connections on my circuit aren't faulty in some way. Sometimes I even go so far as to unplug and hard reset everything in my Arduino, just to be sure I didn't somehow confuse it along the way. Arduinos can be kind of temperamental, so you'd be surprised how often that actually works. But if I've checked all of those things and still have an error, then it's likely a runtime error. And you can use serial print to send information from your Arduino to your computer. We've done this before, actually, like in the last episode when they had the Arduino introduce me, or in our other videos when we monitored the light values to discern which thresholds to put in for our light sensors. This same function can be put into scopes of functions to give us a readout of what we're seeing at different points in the code to better identify where the issues lie within what we're doing. At its most basic, we can use the serial print function to show us values in a sequence, which is what the serial library is meant for. Let's take this example. So let's say what I want to do is see a sequence of numbers that are being sent from my Arduino to the computer itself. Now, the way I would do that is I would establish a variable and then give the Arduino a set of instructions to show me that number and iterate it over time. In this case, what I've done is I've created the variable cool, and set it equal to 10. Then I've given it further instructions that every time it sees cool, it should add 1 to that number. However, by using serial print in here, it now sees that every time there's cool, it should send that to the serial monitor so I can verify that Arduino is actually doing that. Now, if I didn't have this in here, the Arduino would still be doing that. It would still be running that in its memory, but I just wouldn't be able to see it. So by having this set up the way it is, and by using this serial print, I can verify this, upload it to my Arduino, and then open the serial monitor. And I can see here, I'm going to unclick auto scroll. I can see here that my numbers go up by 1 every single time, starting all the way back if I scroll back at 10, because that was what my variable was initially, and then I wanted it to go up by 1 each time. This serial print function is something that we can input into different parts of functions or into different functions in different loops, anywhere we'd like to check what's going on and make sure that the information from the Arduino is actually being sent to the computer properly, or vice versa. So I could input this multiple times into my code into different functions just to check along the way. Is it doing what I need it to at this point? Great, I'm going to move it somewhere else, see if it's doing what I need to at that point. So the big tips from this video are: 1, sometimes you just got to Google it. 2, verify, verify, verify. The more you verify, the faster you're going to find your issues. 3, learn to read those error codes so when you do have issues, you know what you're looking for. And 4, use the serial print function to check what information is being sent between your computer and your Arduino. That's all for this video. Check out episode 4 for tips on what the different abbreviations and the terms in your code mean.